All right, good morning. Welcome to online math class. What we're going to be studying today will be ordering fractions, and there's a couple of ways to look at this. First, we're going to be talking about benchmark fraction again. So how do you compare two other fractions to a benchmark? And the benchmark, of course, is looking at half. I'll draw some pictures to remind you. And then I want to talk about the old lady algorithm, basically how you get denominators, the bottom number in a fraction, to all equal one another so you can see comparatively what they look like. So I'll teach you a couple of different ways. So first the model, the visual, and then go ahead and showing you how to use the algorithm. All right, so it says there are several ways to order fractions. In many cases, reasoning and number sense can be applied, as in the use of a benchmark fraction. Today we will use traditional method or algorithm to compare and order fractions. We will learn how to use equivalent fractions. So I'm going to read you a problem. I'm going to put the three different fractions up here, and I'll talk a little bit about how we would use two different models to look at them. So Max skated 2/5 of a mile, Carlos skated 3/5 of a mile, and Pedro skated 1/2 of a mile. Write these distances in order from least to greatest. In order, you can use fraction strips, number sense to decide. So let's write these out. So the first one that was given was 2/5. The second one that was given was 3/5. And the last one that was given was 1/2. Excuse me. So I see three different fractions, and basically if we were using number strips, I'm going to draw three different strips. Not really even, huh? So the first one is 1/2. So you remember we talked about that being very easy to compare. So that's 1/2. And then these have 5 as a denominator, so I'm going to take this bar and divide it up into 5. Fifths are tough, so I'll try my best. 1, 2, 3. Oh dear, kind of. 1, 2, 3, 4, 5. Well, I'm going to fix this right here, and I'm just going to go down just a little bit more. And then I'm going to fix my 1/2 and make it really go 1/2. Okay, so there's our fractions. We'll say that these are all fifths, so represented as 1. My marker's kind of dying. Hold on. Represented as 1/5, 1/5, 1/5, 1/5, and 1/5. Same thing with this one, since these two denominators are 5. 1/5, 1/5, 1/5, and 1/5. So let's first focus on 2/5. So what does that look like? There's 1, there's 2. Now I want to just remind you again, our first fraction was 1/2. So you can say that 2/5 technically are less than 1/2. And then finally, we have 3/5. 1, 2, and 3. So visually, 3/5 is greater than 1/2. So if we were to order these from least to greatest, it would first be 2/5, then 3/5, and then whoa, sorry. It'd be 1/2, and then it would be 3/5. So that's the visual model showing you how to order these fractions from least to greatest. Now I want to show you a traditional algorithm. I do have my weight in my pocket. So that's the model, which does take a little bit more time, and you have to have fraction strips really for it to be even. And you probably find some examples in your book on that. So if we did traditional old lady algorithm, we see the denominators of 5, 5, and 2. And we need to find a common factor, or common multiple that these both have in common. So I think about, well, 5 times 2 is 10, 5 times 2 is 10, and 2 times 5 is 10. So I can get them all to 10 as a denominator. So I rewrite them like this, with a 10 underneath. My marker's kind of dying. I don't have my good ones today. And in order to do that, we talked a little bit about fair is fair in the world of fractions. So you have to multiply top and bottom by the same amount. So 2 times 5 is 10. 2 times 2 is 4. Okay. We go to the next one. We know that we're going to do the same here to get that to 10. So we just focus on 3 times 2 is 6. And then finally here, we have to multiply this by 5 and this by 5, which gives us another name for 1/2. So you kind of see we have the 3 different fractions, and if we order them from least to greatest, this is the smallest, this is the middle, and this is the largest. And that's what we kind of said. If we were to rewrite this over, we'd have to put them back into original order. So it would be, again, the very bottom, 2/5, 1/2, and 6, and 3/5. So that's ordering fractions from least to greatest with 2 different methods, model and then traditional algorithm. Okay, let's do one more example from the book that you guys might be able to see. It's actually, we'll just do one of the examples from the group practice, and I'll just take number 1. Number 1 in your guided practice looks like this: 2/3, 1/2, and 5/12. Okay, you're probably already seeing a common factor we can get them all to with algorithm, but let's just draw that model again. The fraction strips make it a little bit easier, which you don't have. So again, we're dealing with 1/2. That's easy. Let's go ahead and prepare that. Then the largest one I see is 12ths. The smallest one I see is thirds. So thirds, fairly easy. Okay, so here's 1/2. We can go ahead and shade that in. Here's 2/3. We can shade that in. Okay, so that leaves 1/3 over here. And then finally we have 12ths. And 12ths, remember we talked about this, you could take the thirds and then divide them each into a fourth. So you go half again, half again, half again. And it's not truly even. But if we had 5/12ths, you can, each one of these, remember, is 1/12. So instead of taking the entire time and writing each one of those out, I'll just do 5 of them. And so I will shade in 5/12ths. This is tricky because you can see here's 1/2. There's that mark. Okay. Darken that in a little bit more. Here's 2/3. It's fairly large. It's almost 1 whole if you think about it, because it's only 1/3 left to 1 whole. And then down here at the bottom, this is what 5/12ths equals. Benchmark fraction says half of 12 is 6. So if we look here, 5 is almost half of 12. So that's the way you use that benchmark fraction. So you know automatically this is going to be less than this. This one is fairly large, and we can kind of see that here. Here's the traditional algorithm when you compare them. Finding a common denominator for all of these. So I'm going to go with 12. So I'm going to leave 5/12ths by itself since it's already to 12. Then I'm going to work with 1/2. I know I want to get that to 12, and I want to work with 2/3 and get that to 12. So now it's multiplying top and bottom by something to get to 12. So 3 times 4 is 12. So that means the top is going to be 8/12ths. So again, that's 2/3 becomes 8/12. You can already know that's a pretty big fraction. And then of course here we multiplied this by 6 and 6/12. So another name for 1/2 is 6/12ths. So if we ordered these from least to greatest, we'd have to, our smallest one, of course, would be 5/12ths. The middle one is the benchmark fraction, 6/12ths. And then the largest one is 2/3, or another name for that is 8/12ths. So it'll ask you to rewrite them in order from least to greatest. So you have to take them back to their original form. 1/2, and then lastly 2/3. Okay. So those are just 2 different ways to try that. Thanks. That's a quick lesson. Bye, kiddos.